Hey, welcome back. No fancy rock and roller this week. It's just neon colored Mr. Young. So I got this shirt for $4 at Fred Meyer's. It's an Under Armour. It's nice. $4 at Fred Meyer's. That's pretty cheap. All right, this week we're going to look at graphing sine function. Okay, you're going to have this will be kind of a longish video. Because there's a lot to cover. Okay, the nice thing is graphing sine is probably easier than some of the other stuff we've been doing this chapter. I know it's a hard chapter, and I know it's super difficult to learn with me recording YouTube videos and you watching them. So if you're struggling, please email me so we can set up like a Google Meet or something, okay? I would love to Zoom Meet or Google Meet with you guys and see you face to face, and I really think it would help a lot of you who are struggling, okay? I'm available almost any time. So you let me know what works for you and we'll figure it out, okay? All right, graphing sine. Before we do that, I'm going to make a little table here. The ones that I want you to know are these blue ones, okay? Those are the 5 important points. I'm going to throw a few other ones in there because it will help us sort of see what the graph looks like, okay? So a lot of these you should have from your unit circle and special triangle thing, okay? But the sine of 0 is 0, okay? The sine of pi over 6 is 1/2. That's on your special triangle sheet. Okay, pi over 6 is 30 degrees. The sine of pi over 4 is square root of 2 over 2, which is 0.707. Okay, the sine of pi over 3, or 60 degrees, is square root of 3 over 2, which is 0.866. Okay. Square root of 90 degrees, which you should know, and is on your sheet, is 1. Okay, that's one of the other important numbers. 2 pi over 3, the reference angle on that, if you drew that angle, it would look like this. So there's 2 pi over 3. Remember last week we learned about reference angles. So if we drew a line down to the x-axis, that angle right there is 60 degrees, or pi over 3. So the sine is going to be the same, 0.866. And we know that is positive because it's sine, and all students take calculus. That's S. Okay? 3 pi over 4, the reference angle of that would be 45 degrees. And that means that it is 0.707. And 5 pi over 6, if you drew that angle, our reference angle right here would be pi over 6. So it's going to be 1/2 again. Okay? When you get back to pi, the sine of pi is 0. That is on your unit circle sheet. Okay? Another one that I want you to remember, 3 pi over 2, which is 270 degrees, the sine is -1. And 2 pi, if we went all the way around, we would be right back where we started, so the sine is going to be 0 again. Okay? So our 5 important points for this function, for the parent function, are the blue ones. Okay, the other ones are just going to help us graph it. Here's the weird thing about sine and cosine, which we'll do next week. Okay, most of the time when we draw a graph, we have right, 1, 2, 3, 4 on the y-axis. On the x-axis we would have 1, 2, 3, 4. It's going to be a little bit different with these, because our x-axis is going to be radians. Okay, so I put 2 pi there. That means this is 1 pi. That means this is pi over 2. So let's see, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And then I'm going to do the same thing this way. -2 pi, -pi, -3 pi over 2, -pi over 2. Okay, so this is a good scale usually for your x-axis. Is mark 2 pi on one end, -2 pi on the other end, and then kind of split it up into even spaces. Okay, so that's a little bit different in that our x-axis is in radians. Okay, now we're going to graph this. Let's see, 0, 0. It's right there. Pi over 6 and 1/2. So pi over 6 is 1/3 of this. So 1/2 is about there. pi over 4 is half of pi over 2. So we're at 0.7, about there. This is 2/3 of pi over 2. It's at 0.86. And when we get to pi over 2, it's at 1. Okay? And then it kind of, this one's not a very good spot, kind of starts dropping back down. And by the time we get to pi, it's back to 0. Okay? 3 pi over 2 is -1, and 2 pi is back to 0. So these 5 points here are your important ones. 1, 2, 3, 4, 5. I added these red ones just so you can see that it's curved. It's not like, okay? But this is the shape that it makes, okay? This is called a sine wave, okay? If we go the other way, it's going to be the exact opposite. So instead of going up 1 here, this is going to go down 1, and then it's going to go back up to 0, and then it's going to go to +1, and then back to 0. Okay? Right there, this is the graph for y equals sine of x. Okay? Notice it repeats, right? And if we kept going, it would repeat this wave forever and ever and ever. Okay? So since it keeps going forever and ever, the domain of this function is all real numbers. And then the range, let's see, the highest it ever gets is 1. The lowest it ever gets is 0. So our range, the y value can be greater than or equal to -1, less than or equal to 1. Okay? This is a typical sine wave. Couple kind of pieces of it. Notice it starts at 0, goes up through 0, goes down back to 0, and then it starts repeating. So this one section where it goes up, down, and back to 0, that is called a cycle. Okay? This is always a fun section to teach with teenage boys because you guys are immature, but that's a cycle right there, one time through the wave, sort of. The length of time that it takes to make it through a cycle is called a period. Okay, so on this one the period is 2 pi. That means it takes 2 pi radians to make it all the way through one cycle. Okay, couple other little vocabulary things on this one. The x-axis is what's called the midline. That splits the graph exactly in half. Okay? If you can't tell by looking what the midline is, you can take the highest point and the lowest point and average them together. So 1 plus -1 would be 0. 0 divided by 2 is 2. So the midline of this one is y equals 0. You can probably tell just by looking on that one. Okay? So the midline is the line that goes through the middle. It's not the bottom, not the top, it's the middle. And then the last kind of vocab is the amplitude. The amplitude is the height above the midline. Okay? So if the highest it ever gets is 1 and the midline is 0, then the amplitude of this one is 1. Okay? If we, we'll get to stretches in a minute. Okay? So that's your parent function. Remember these 5 points. I would even write them down if I were you. Okay, you're going to need to know those. And then just remember that this repeats every time. Okay? Let's look at a couple more. Okay, we're going to, just like we've been doing all year, we're going to do transformations on these. And the nice thing is, the transformations are the same as they've been all year. Okay? So this, we have a number at the very front. What kind of a transformation is that? It's a vertical stretch, right? So it's going to be a vertical stretch of 3. So all we're going to do is draw our normal graph. Let's see, we'll go 2 pi, pi, pi over 2, 3 pi over 2, -2 pi. Okay, so our normal graph starts at 0, 0. Since we have a vertical stretch of 3, all that does is multiply all the y values by 3. 3 times 0 is still 3. If we go over pi over 2, 1 times 3 is 3. Back to 0. -1 times 3 is -3. Back to 0. And then when you graph these, I always want you to put at least 2 full cycles, okay? So it needs to go at least 2 times through the whole process. So here is our graph for 3 sine x. Okay? Remember I said the amplitude was how high above the midline it goes? Well, the midline on this is still x equals 0. And the highest it gets is 3, so the amplitude of this is 3. Okay? Which is that number. So whatever this number is going to be your amplitude. That's how high above the midline it'll get. Let's see. The period on this, it's still 2 pi, right? It takes 2 pi to get all the way through. Okay, and I have 2 full cycles in there. Okay, another common mistake you guys will make, I'm not exactly sure why, but you're usually really good. You go here, and then you go up there, and then a lot of times you guys will skip this point, and so the third point you draw will be here. Okay, so make sure you put all 5 points in there each time. Okay, so just like always, A at the beginning is a vertical stretch. It changes the amplitude. Let's try a couple more. How about this one? Negative, no, actually, sorry. Let's try this one. Sine of x plus 2. Okay, what kind of a transformation is it if we add a number at the end? That's a vertical shift, right? So on a sine or cosine graph, what that vertical shift does is it moves the midline. So instead of our midline being 0, since it has a vertical shift of 2, our midline is going to be 2. So what I like to do is put a dashed line through 2, and that tells me that's kind of my new starting point. Okay? Since that's the only transformation, we're just going to use these points, but instead of being 0, 0, since our midline is up there at 2, I'm going to put my first dot on 2. Okay? And then I'm going to go 1 above that. I'm going to go back to 0. I'm going to go 1 below the midline, and then back to 0. The other way you could think about it is just graph these points and move all of them up 2. You'll get the same thing. Okay, I think in the long run you'll be better off actually drawing the new midline. So there's our graph. Okay, period is still 2 pi. It takes 2 pi to get all the way through there. Our midline is positive 2. I guess that's it. Okay? So adding a number at the end, just like it's been all year, is a vertical shift. Okay? It moves the midline up 2. Or it moves all the points up 2 if you want. Okay, couple more. This one we're going to throw 2 transformations in at once. Okay? So it's going to be negative sine of x plus pi over 4. Okay, you guys should know by now that if you put a negative in the front, that's a reflection over the x-axis. I don't know if you could hear that or not. There's birds outside my window cheeping loudly. I don't know if the camera picked that up. Alright, so we're going to have a reflection over the x-axis. That means all the y's are going to change signs. And then the other thing, what's that plus pi over 4? Remember, if you get a number inside the parentheses, that's a horizontal shift, and it's backwards. So if it says plus pi over 4, it actually means we're going to move all the dots pi over 4 that way. Right? We're going to move them left. So I'll do this one with red, and then we'll shift all the dots. Okay? So we got 0, 0. And then instead of pi over 2 positive 1, it's going to be pi over 2 negative 1. I guess I should have put a... there we go. And then back to 0. And then instead of negative 1, it's going to be positive 1. Back to 0. Same thing on the other side. Instead of going down 1 here, though, it's going to go up 1. There, there, there. So you've probably noticed once you get those first 5 dots in, the rest of them sort of draw themselves once you kind of realize what it looks like. Okay, that's everything with the reflection. Now we're going to take all these dots and move them pi over 4 in this direction. Okay, remember if this is pi, half of that must be pi over 2. and half of that would be pi over 4. So I'm moving all these red dots half a line that way. So this one will end up here. This one will end up here. There. 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 So here is my graph. Okay? It's got the reflection, so instead of normally it starts here and goes up, right? Now it's starting and going down. And then we took all the dots and moved them pi over 4 that way. Okay? A little bit tricky, but it's still the same transformations we've been doing all year. Okay? Notice the period of this one is still 2 pi, right? If we were to go from this point here, which is negative pi over 4, to where it gets back to 0 here, that would be 2 pi. So our period is still 2 pi. Okay, last one. All right, let's try this one. Y equals sine of 2x. Okay, this is the one kind of tricky one. Even it's not super bad, okay? What kind of a transformation is that if we have a number in the parentheses with the x? That is a horizontal stretch or shrink, right? But remember it's backwards, so we have to take this number and flip it over. Since 1/2 is less than 1, this would be a horizontal shrink. So it's going to shrink everything this way, okay? So one way you could do this is multiply all the x values by 1/2. We're going to do it a slightly different way, okay? There's a formula that says the period is 2 pi divided by b. b is whatever this number in front of the x is. Okay, all the other ones we did, this was just x, so the number was 1. 2 pi divided by 1 is 2 pi, so our period was 2 pi on all of those. This one, since we have a 2 there, that means our period is pi. That means every pi radians, it's going to make it all the way through one cycle, okay? So we're still going to start at 0, 0, and by the time we get to 1 pi, it's going to be back where it started, okay? So we need to fit all 5 points in that little section, okay? What it ends up looking like is instead of being pi over 2, 1, it's half of that. So pi over 4, 1, and then gets back to 0 at pi over 2 instead of pi, and then down there. And then now we got all 5, so now we can see the pattern. Up, down, bottom, back. Same thing here. Okay, so let's see. Okay, so there's a graph with B, with the horizontal shrink in this case. You could also get a horizontal stretch if that was a 1/2. 2 pi divided by 1/2. Remember when you divide by fractions? That's the same as multiplying by the reciprocal. 2 pi times 2 is 4 pi. So if that was a 1/2, it would take us 4 pi to make it all the way through one cycle. Okay? On this case, since it was a 2, it was a horizontal shrink. We found our new period was pi, so we knew that it had to make it all the way through a cycle by the time it got back to pi. Okay, so now our period is pi, and let's see, we have 1, 2, 3, 4. We got 4 cycles in our graph there. Okay, that is it. It's a lot of stuff I threw at you. This might be a good video to maybe watch twice, I don't know. I'll have a little notes thing that I'll put on Google Classroom, and I'm going to try to just give you maybe like 6 graphs to do maybe. I don't want to give you a ton of them because there's a lot of stuff here, okay? Do your best. Remember, if you have questions, please email me your questions, or email and say, hey, I want to Google Meet, or email me and say, let's meet at Bakerview, play around at disc golf, and then do math. I don't know, whatever. Email me if you need help, please, okay? That is it. Good luck. Do your best. If you understand this, cosine next week will be super easy. So, okay? 1 month of school left, so we got 4 weeks. That's almost no time at all. We're almost done, okay? Let's push through, persevere, and any other words you can think of that mean persevere. Stay strong, be resilient, all that stuff. So long.